Datuk Lim Kok Boon, President, Malaysian Plastics Manufacturers Association, MPMA, Mr. Eddie Fong, Chairman of MPMA PLASTECH MONTH 2021 and Secretary General of MPMA, distinguished guests, ladies and gentlemen, welcome to the 8th webinar in the MPMA PLASTECH MONTH 2021 webinar series entitled Working with Post-Consumer Recycled Materials. To begin the webinar today, let me run through the etiquette or rules of the webinar. You would notice that we have muted and turned off video for all participants. This is because we are using a conference platform on Zoom, and this feature is activated to ensure that there is no disruptions to the speakers during the webinar. Participants may ask or post questions related to the presentations in the chat box during the webinar. The speakers will only answer questions that are clearly written and based on the presentations. Kindly refrain from marketing your goods and services in the chat box. Kindly also refrain from posting comments or remarks to questions posted in the chat box. The chat box is only for queries related to the presentations. And lastly, the organizer reserves the right to remove participants who run afoul of the webinar etiquette. The MPMA PLASTECH Month 2021 is brought to you by MPMA with the generous support of sponsors from the Malaysian plastics industry. Please allow me to thank all of our sponsors. Platinum sponsor, Monitor ERP System. Gold sponsors, PT Bobs Jakarta, Milliken Asia Private Limited, NGR Malaysia Sdn Berhad, Petronas Chemicals Group Berhad, Reifenhauser Blown Film GmbH, and Windmuller and Holscher Asia Pacific Company Limited. Silver sponsors, Arbuk Sdn Berhad, Nord Mechanica SPA, and Cispro Software Malaysia Sdn Berhad. Bronze sponsors, Autodesk Malaysia, Ben Mayer Specialties Malaysia PLT, Borouge Private Limited, Husky Injection Molding Systems Malaysia Sdn Berhad, Recommend Malaysia Sdn Berhad, Sigma Soft Sdn Berhad, and Torre Plastics Malaysia Sdn Berhad. And other sponsor, Kryberg TPE Technology Malaysia Sdn Berhad. Thank you once again to all sponsors for making the MPMA PLASTECH Month 2021 a reality. In appreciation to our platinum sponsor, Monitor ERP System, for their contribution towards the event, we will now play Monitor ERP's corporate video. Thank you to Monitor ERP System for your support towards the MPMA PLASTECH Month 2021. Without further ado, let me introduce to you our moderator for today. He is the Deputy Managing Director of Sihau Global Sdn Berhad, a leading manufacturer of plastic pallets in Malaysia. As the Chairman of MPMA Recyclers Subcommittee, he was one of the main curators for the white paper on an advanced plastics recycling industry for Malaysia and the material flow analysis for plastics. He is also the chairman and one of the chief architects of MPMA Plastics Technology Roadmap 2025. It gives me great pleasure to introduce our moderator and Vice President of MPMA, Mr. C.C. Chia. Mr. Chia, I now pass the session to you.
Thank you, Crystal. Thank you. Can you see me well? Can you hear me?
Yes, all good.
Okay, thank you very much. Good afternoon, ladies and gentlemen. First of all, I would like to thank all of you for attending to this afternoon's webinar, yet another session from conference from MPMA in our MPMA PLASTECH Month conference. Today we have a very exciting webinar titled "Working with the Post-Consumer Recycled Material." Ladies and gentlemen, at the last Thursday's MPMA PLASTECH Month session, we had discussed the global progress and the Malaysian direction towards circular economy. The session also explained the relationship between plastics and climate change and the need for the industry to identify and reduce its carbon footprint through life cycle assessment or LCA. Further to this, at last Tuesday's session, we had heard of all the new sustainable plastics packaging technologies which have been developed to make packaging more recyclable, to move the industry towards the circular economy. Today's session, we will dive deeper into the area of circular economy, in which recycling is the essential in achieving plastic circularity. We will hear from numerous experts from the plastic recycling sectors on how to work with post-consumer recycled materials. Yeah, we have lined up indeed a few very qualified speakers from the world-leading technology in processing technology or material technologies this afternoon. All right, so without further ado, first let me introduce the first two speakers for this afternoon. The first two speakers are from Ms. Danielle Lee and Ms. Huang Yi Chen from Dow, Malaysia. Danielle Lee is the Dow Asia Pacific Application Development Leader. She has more than 15 years of experience in the technical field and collaborates with regional customers to develop and improve their flexible packaging in applications such as industrial, food, and hygiene. Huang Yi, she will come up after Daniel, is the end user and market development manager for Southeast Asia, Australia, and New Zealand for Dow Chemical. She has more than 6 years of experience in Dow, working with end users and brand owners in diverse industries spanning from F&B, industrial, and hygiene applications. Huang Yi is a regular keynote speaker in conferences around the region for Dow Chemical. Yes, so without further ado, I would like to pass the floor to Ms. Danielle Lee.
Hi, I'm Huang Yi, and I'll be starting the session today.
Okay, Huang Yi will start first, sorry.
No worries. Good afternoon, everyone. It is my pleasure today to introduce Dow and our PCR solution to you. Please don't hesitate to send in your questions, and we will try our best to answer them at the end of the session. To those unfamiliar with Dow, or perhaps only know us as a chemical company, Dow may seem overwhelming in the number of industries we participate in and the range of products we provide. At the heart of what is driving this global company is a single question: how can we work together to solve today's complex challenges? At Dow, our people use science and collaboration to create what matters most to our customers, society, and our planet. Our ambition to be the world's most innovative, customer-centric, inclusive, and sustainable material science company drives best-in-class performance in a culture where new ideas thrive. Let us take a closer look at Dow's sustainability journey, which started all the way back in 1995. It was very much focused on what was internal in the company, reducing our footprint in terms of safety, improving operational efficiency, and the impact was mainly limited to Dow. After accomplishing our 10th year journey to EH&S excellence, Dow announced our 2015 sustainability goals, which focuses on how we can provide product solutions to enable our customers to solve some of the world's most pressing challenges like water and food scarcity. This shifts our internal view to external and how we want to leave our handprint to the world. In 2016, Dow released our most ambitious sustainability goals yet for 2025. Not only are we focusing on how Dow can operate in an even more sustainable manner moving forward, but providing a blueprint for the rest of the industry and leading the changes to come, such as adding PCR solutions to our virgin product offerings. 80% of our R&D projects focuses on climate protection, the the circular economy, and safer materials. And 48% of our 2020 sales were from products addressing real challenges. Our sustainability journey continues to evolve as we get closer to reaching our ambitious 2025 sustainability goals. By forging ahead with collaborations from like-minded partners, we can envision a stronger future together through a more sustainable planet and society. Moving down from the Dow corporate sustainability strategy to the Dow packaging and specialty plastics business sustainability strategy, the focus is on the advancing a circular economy target. Our business global strategy is to create plastics for the circular world. Our three-part strategy represents our commitment to finding ways in which we can continue to provide the convenience of plastic, the protection of plastic, the affordability and safety of plastic, while ensuring that none of that plastic ends up in the environment or is lost to landfill. This we will do by delivering circular economy solutions through breakthrough innovations, keeping plastic out of the environment, by keeping not just Dow, our customers, but also value chain partners accountable through Operation Clean Sweep, and to amplify our efforts through partnerships within the industry, such as the Alliance to End Plastic Waste, our collaborations with numerous NGOs, and much more. Upon realizing that we can and should do even more as we come to the last few years of our third phase of sustainability targets, we have announced our 2030 vision. The products we sell into packaging applications will be 100% reusable, recyclable, compostable, or biodegradable by 2030. This may sound familiar to some of you, as similar to what many brand owners have already pledged. Led by the Ellen MacArthur Foundation in collaboration with the UN Environment Program, the global commitment has united more than 500 organizations behind a common vision of a circular economy for plastics. Driven by the goal of tackling plastic pollution at its source, companies representing 20% of all plastic packaging produced globally have committed to ambitious 2025 targets to help realize that common vision. And this global commitment to increase recycled content in their packaging to an average of 22% by 2025 amounts to a demand of 5 million tons of recycled plastics. In order to satisfy this demand for PCR, Dow has been investing heavily in not just R&D, but also in our assets to allow for this pivot to green plastics. Unpacking the commitment from the brand owners, the three key components to the pledge that need to be fulfilled by 2025. The first is the inclusion of PCR in the packaging. The second is enabling the new packaging to be recyclable. And the third is non-fossil fuel-based plastics for the new packaging. Dow is delivering our solutions to fulfill the recycle component with our 25% and above PCR in applications like collision shrink film and other protective packaging. With our design for recyclability category of solutions like monomaterial or PE pouches, we are fulfilling the recyclable component of the pledge. Lastly, reducing our dependence on fossil fuel and moving to renewable materials, we have introduced our 100% bio-based resin made from non-food competing sources. Now, as one of the largest virgin plastic manufacturers in the world, you may be curious to understand how we plan to tackle this shift in demand and drive towards plastic circularity. We have housed it under 4 pillars. The first and most crucial is design for recyclability, which if you had paid attention to the previous session, I believe was on the 23rd of November, my counterpart Jason would have already taken you through much of the content of that. From the birth and conception of the packaging, we need to make sure that the first step is placed correctly and enables the rest of the steps to follow. Dow has our own Recycle Ready platform and special technology, which empowers currently non-recyclable structures like nylon PE to be recycled as if it was a monomaterial structure. The second pillar is in mechanical recycling. We are working with our partners in the value chain to improve upon the infrastructure of recycling and also improving the quality of recyclates through Dow technology. The third pillar is feedstock recycling solutions, and we're currently evaluating and also piloting different options such as pyrolysis and gasification. The fourth pillar is innovation and new business development, where we explore the previously uncharted territories such as bio-based plastics. In the pillar of mechanical recycling, Dow has been working with the whole value chain, from the recyclers, equipment manufacturers, brand owners, converters, retailers, for the product and application development to ensure that our PCR not only fulfills the performance requirements of the brand owners, but is on par with virgin resins to enable higher loading of PCR in all of the key applications that we have targeted. Now, I shall pass the time on to Daniel, who will take you through the details of our PCR solution.
Hi, everyone. Thank you, Wang Yi. Okay, the remaining slide, let me run through with you. So here takes a look on a glance of Dow Global Pack Studio locations. We have 2 in North America, 1 in Latin America, 2 in Europe, and 3 in Asia. So Pack Studio is a place where Dow customers' innovative ideas or packaging needs get addressed through collaborations. Dow customers' innovative ideas or packaging needs get addressed through collaborations. Dow customers value the lab capabilities and also expertise that help them solve packaging problems and also develop better solutions. And the resin technologies from Dow suitable for mechanical recycling can be divided into 3 types. The high performance resins are the enhancers to boost the properties, compatibilizers to harmonize different polymers and impact modifiers to increase the impact as the name suggests. All 3 can actually be used with post-industrial waste as well as post-consumer waste. So in April 2020, we launched the first made in Asia PCR resin into the market, named XUS 60921.01. It's a 1 pellet solution, contains 40% of PCR, targeting at collagen shrink application. The launch has made headlines on main social media and also appeared in various industry-leading magazines. In November 2020, it won a Sustainability Award in China. And Dow's PCR resin is a formulated one pellet resin with 40% of PCR content. Okay, it's made with post-consumer waste collected within Asia and manufactured in China. The resin is designed to be a direct drop-in for majority collagen shrink film in the market without modification of current film structure. So depending on the film layer ratio, the PCR resin can deliver between 13 to 24% of PCR. Since its launch in Asia, we have received strong interest from brand owners. The main reason collagen shrink is chosen as the first target application for our PCR resin is the market needs. Driven by modern lifestyle and also recent pandemic, consumers are buying groceries online and beverages in one of the frequently ordered and delivered items. Despite Asia being the fastest growing region for e-commerce, the infrastructure makes it challenging for goods to move across intact. The collagen shrink film holding the beverages together serve more than providing convenience, but an important protection layer against physical abuse. In recent years, consumers are paying more attention to sustainability. When consumers discard the collagen shrink film, the waste itself is a virtual impact on the consumers and thus a call for greener packaging. Incorporating PCR content in the film not only makes it greener, but also retain the intended functionalities of the film. The technology today enable making high qualities of PCR resins like this to ensure the performance is not compromised. Okay. In terms of sustainability impact, the XUS 60921.01 PCR resin can reduce carbon footprints and EPR fees. Detailed calculation is available upon request. Designed to meet sustainability goals, the resin works to enhance the reputation of a brand. So the consistency of the film quality means lesser waste caused by broken packaging. The best is the film made of this PCR is fully recyclable and end of life, which is important part of closing the loop. Here's a simple comparison of potential environmental benefits between PCR resin and virgin resin. The formulated XUS 60921.01 gives carbon saving of 0.32 kilogram and water consumption of saving of 0.59 liters. This environmental benefit becomes substantial when PCR resin is consumed in metric ton or kiloton. Here's a recap of benefits of Dow's formulated PCR resin. The PCR resin keeps waste away from landfill, oceans, and environment through mechanical recycling. The technology advancement today allow us to produce consistent quality and also high performance PCR resin, which in turn reduce the dependency of virgin plastics from fossil fuels. The PCR resin delivers lower carbon footprints, energy savings, and social economic benefits in the value chain.
Okay, up next, we have a customer testimony from Thai Packaging, one of the leaders in protective packaging in Thailand, to share their experience of working with Dow on our PCR solution and how the market has responded to their sustainable collision shrink film.
Are you okay? Are you playing a video for us or no?
Yes.
Okay.
Sorry. Okay. You can hear that, right?
Hello everyone. Please allow me to introduce myself. My name is Thanadet Rabgopchai, or you call me Trong. I am the Assistant Managing Director of Thai Packaging Manufacturer. I'm more than happy to be your interviewing guest today. So here is some examples of PCR collision shrink film that we are currently supplying to our customers. So in front of you right now, we have product in rolls and in finished products after shrink. What you can see, we can develop the PCR resin into the film which has the same physical properties, just like using the virgin resins. Our sustainability goal is to be part of Thai communities, providing cutting-edge innovation for modern living flexible packaging, with our concern of 3 SAW 1 RAW strategies. The first SAW, develop the quality products and services together with innovation alongside with our customers. The second SAW, dedicate and sharing passion to our stakeholders. Let them be part of our family, which is Thai Packaging Family, Happy and Smart. The third SAW, deliver the IPOS standardized system to our supply chain to reduce the mistakes in our every processes from beginning to the end. And the last, RAW, environmental comes first. As packaging producer, we never stop develop the environmental friendly products and start the circular economy in Thailand is our ultimate goal. Dow Chemical and Thai Packaging have been a good partner for a while. We share the same chemistry of business purpose, talking about the same page, driving the innovation of packaging, pushing forward the circular economy, well known and have high standard of profession, capable and more than enough to supply our needs. The Dow PCR resin is answering the questions that people have been asking today about how to bring the plastic waste back to upcycling packaging. So we see the opportunity to lead this innovation and set the circular economy in Thailand. So today I can say that Thai people have realized and knew it from bottom of their heart that they have to do something about it. Some of them have done so many things for better environment. It highly depends on how much they react to it. For us, Thai packaging have been settled up the sustainable goals for a long time and continuously push forward the better living societies in Thailand. So far, the markets have responded to the issues to a certain extent. For example, eliminate the plastic waste, plastic bag in convenience stores and supermarkets. So to bring our plastic back to circular economy is still very challenging. Across, yes, mostly for the brand owners and organizations across the supply chain. For the end users, they are starting to understand how to get involved and being part of the circular economy. They still need more education and little push from government NGOs and private sectors. Thai packaging will continue to expand the value of PCR across wide range products. Also, Thai packaging will continue to lead the environmental friendly and eco-friendly packaging into the markets. Dow Thailand constantly shows the excellent collaboration during the development. We also expected that, together with Dow, we share the technologies to drive the sustainable solution in the future. Increase the economy of scale, cost and process management, also educate the markets as now it is safe to use. I think Thai people start to know what to recycle, what is PIR, what is PCR. For the large customer that we have, together with Thai packaging along with Dow Chemical, we are the key factors to drive and impact the markets. However, we still have a lot to do on how to come up with strategies and make it possible for all customers.
Okay, I know that this short presentation is only a tantalizing appetizer to the full offerings of Dow. Sustainability is the key issue of our time, and the great news is that we're all in this together. And I believe that as an industry, we're moving in the right direction. No clearer evidence in that than what you have already seen from all the various different commercializations around Asia Pacific and the world. Do feel free to reach out to me, Daniel, or your local Dow representative for more information. We're delighted to share our knowledge and experience with you. Thank you all very much for your time today, and I look forward to your questions in the Q&A session later. Thank you.
Well, thank you. Thank you, Huan Yi, and thank you, Daniel, for two lovely presentations. I mean, I've always known Dow. I've known Dow for a long time and always known Dow as a technology provider of top grade virgin material for packaging solution. But now, with the PCR resins that is as good as virgin resin, that is fantastic. I mean, the string film that I saw from the video look as good as string film that's made from virgin material. Fantastic. I mean,
Yes.
I'm in recycling line, so I have seen a lot of recycled material. They don't look as good as this. Here to this. Great.
Thank
great.
you.
Yeah, great. Okay, then I think let's move on to the second presentation. We would like to invite Miss JC Lim from Borouge. She's going to deliver her presentation, Enabling Tomorrow's Packaging Solutions. Ms. JC Lim is the Application Marketing Manager for Rigid Packaging in Borouge. She's based in Singapore. JC is responsible for driving future profitable growth and enhancing the sustainability impact of Borouge packaging business and steering it towards the next generation of value creation solutions. I believe JC will be assisted by her colleague, Mr. Kiafa Ng, who is the Technical Service Manager, in answering any technical questions, probably now or later at the Q&A session. So JC, You may have the floor.
Hi, thank you for the introduction, Mr. Chase. So yes, I'm here to show and share with you how Baruch enable tomorrow's packaging solution. But before I do that, I will first give a quick introduction to Baruch for those of you that's not familiar with us. So Baruch, we are a leading provider of innovative value-creating PP and PE solutions across various markets in Asia Pacific, in China, Southeast Asia, ANZ, Middle East, Africa, and the Indian subcontinent. We are part of a global polyolefins family and are owned by the Abu Dhabi National Oil Company and Borealis, which is headquartered in Vienna. We have the world's largest integrated polyolefin complexes, and we have the ambition to further expand our current capacity by 2030. And we have more than 3,000 employees globally. And to support this growth, we have established a state-of-the-art innovation center and packaging center of excellence in the UAE, and also an application center in Shanghai. And today's webinar focuses on recycling and the recycling solutions that are available in the value chain to support and drive recyclability. And what I'm sharing today will also touch on those solutions. But before I get down to that, I would first like to take a holistic view on packaging sustainability. And from that angle, we see sustainability in packaging as a combination of the following four main elements. So first, we have content protection, which is the fundamental purpose for packaging. And this protects the goods from any damage that could happen during transport, handling, and storage. And a lot of times, consumers forget that content protection also reduces waste, especially when it comes to food. And plastic food packaging reduces food waste by preventing damage during transport and significantly extends shelf life. The carbon footprint of food loss and waste is about 5 times higher than the impact of producing or optimizing plastic packaging involved. And this makes the benefit of reducing emissions by preventing food waste far greater than the environmental impacts of producing or optimizing the packaging involved. And the second element is, of course, leakage into the environment. The overwhelming amount of plastic waste that are in the oceans and the continued leakage of them have already prompted very strong responses across the globe. And everyone agrees with the need to minimize materials that are leaking into the natural environment. And consumer sentiments against plastics have also been central to a lot of decisions undertaken by global brand owners to commit to higher standards of product design and sustainability target. And there have also been tremendous efforts within the plastic and packaging industry to set up waste management systems to address the issue from the source. And next, we have carbon footprint, which is measured by the total greenhouse emission generated. And we should take an all-rounded approach when looking at the carbon footprint of the package, taking into account the full life cycle and across the value chain. And factors such as the weight of the pack, the production energy usage, and transport footprint should all be considered. And finally, there is recyclability and recycled content. And this has been the packaging industry's main focus in recent years. And the case for this, as presented, as shared with from Dal earlier, is to drive recyclability and also reduce pressure on natural resources, hence improve the overall sustainability performance of packaging. And today, in addition to providing the traditional properties of protection, of advertising, and providing product information, packaging must also be sustainable, to use as little material as possible with the least carbon footprint, and what material it uses must also be reusable, renewable, or recyclable. So all the 4 sustainability elements I shared here are interrelated, and there are also trade-offs to consider when thinking about how to optimize the overall sustainability in packaging. And with this understanding of packaging sustainability, I will next share with you what are the actions to drive sustainable packaging solutions. And they are, first, to provide solutions that are designed for reusable applications, hence reducing unnecessary use of packaging. We will also enable our customers and value chain partners to achieve lightweighting and down gauging, hence using packaging at an optimal level. Our solutions also drive efficient packaging by increasing productivity, driving energy savings, and reducing transportation footprint. We also promote solutions and concepts that will enable fully recyclable package designs for greater recyclability, and we drive circularity and provide customers with solutions that allows the increased renewable and recycled content in packaging. And now we'll look at the ways our technologies and products enables us to act on these first two elements. So first, we look at how material innovation can help achieve higher efficiency and sustainability in the during production for rigid packaging. And in Baruch, we make this happen through a combination of Borstar PP polymerization and Borstar nucleation technology, or BNT, which allows the product to have increased stiffness without negatively affecting impact, hence allowing for lower wall thickness, enabling the down gauging of the end product. We also allowed for the reduction of energy consumption through the possibility of reducing the extruder temperature. Cycle time reduction can also be achieved through reduced cooling time and easier demolding due to faster crystallization and helping molding customers improve resource efficiency and reduce carbon footprint. The limited impact of coloring on dimensional stability allows fast color change during production without the need to change process parameters. And our portfolio of PP solutions for premium houseware, tin wall packaging, bottles, and customized closures leverage the Borstar and BNT technologies to achieve the above-mentioned benefits. And this is an example of how our rigid packaging solution for premium houseware, RH668, helps drive efficiency in packaging. Because when it comes to applications that requires high clarity of food contact, the current recycling technologies are still in the early stages of development. But it doesn't mean that high clarity of food contact packaging like premium houseware or storage containers cannot drive sustainability or circularity. Because with the right material technology, as I shared in my previous slide, they can have excellent productivity, bringing both energy savings and cost savings for the value chain. And such premium applications are also made durable to drive reusability and are fully recyclable to support circularity. And next, we will look at how to enable greater recyclability in flexible packaging through design, because thoughtful design can play a critical role towards achieving circularity. The way a package is designed will provide the prerequisites for achieving more efficient recyclability. And in flexible packaging, the attention has been on the drive towards monomaterial laminates, and there are webinar segments in this MPMA PLASTECH Month focused on just monomaterial developments. So here are some of the design for recyclability categories of solutions based on Baruch value proposition and differentiated products. We have from the top left, we have the full PE and PP laminate solutions, providing specific performance and functionality. And if required by the application, the presence of other components such as barrier coating material is acceptable with content of less than 5%. There is also oxygen barrier performance. If requiring oxygen barrier performance, we have the metallized full PE film solutions, and the presence of metallized component is acceptable for recycling as the typical content is also less than 5%. There is also the full PE lami tube for applications like toothpaste, where differentiated Baruch high stiffness FB5600 replaces aluminum and provides excellent moisture barrier performance. And over here, number 5, we have MDO film, which is another hot trending topic in the monomaterial space. And Baruch PE grades can be used for replacing PET or PA film as a printing substrate. Another fast developing area is in BOPE, using Baruch PE grade, which provides distinct clarity, flatness, and high stiffness for printing substrate in the full PE film. And finally, there is a more back to the basic approach towards design for recyclability is surface PE that replaces the laminate structure. And this can be printed or non-printed, and it omits lamination without sacrificing the film performance. And here in the next slide, we can see some success stories, both for PE and for PP. On the PE side, we have the rice bag featuring an exclusive matte surface for differentiated marketing appeal to pack high quality rice. And Baruch embossed star is used as the top layer for high quality printing effect, as well as to provide heat transfer surface to cater for wide ceiling temperature differentiation. And there is also shampoo sachets, which has been the target of major brand owners to convert to fully recyclable structures. And here we have an MDO blown film PE solution, which allows for high-speed form fill seal packing with no leakage. And on the right, on the PP side, we have our random material to convert PET and PE laminate to BOPP and blown PP monomaterial structure with success cases in both detergent and food packaging. And finally, I will share how we drive circularity with solutions that allows for increased recycled and renewable content in packaging. On the renewable front, we have Bornewables. So Bornewables is a new portfolio of circular polyolefin products that are produced with renewable feedstock that is derived entirely from waste and residue streams. These premium polyolefins offer the same material performance as virgin polyolefins, and they can be used for any number of applications in all industries, including food contact. And using these innovative and more circular products will help enable our customers to meet their own sustainability targets while maintaining existing quality standards. And the Bornewables are drop-in solutions. They have the same mechanical properties, product safety, and recyclability as virgin material. And when we talk about renewable feedstock, there are actually many different forms, and they are all biomass, which replaces fossil feedstock in the production of polyolefins. But there are actually multiple generations of renewable feedstock. So the first generation of renewable feedstocks are mainly oils derived from food crops. These crops are rich in carbohydrates and can be consumed by humans and animals. And some common examples would be corn, sugarcane, potato, rice, and so on. Then we have the second generation feedstock derived mainly from non-food crops and plants, not suitable for animal or human consumption. For example, oil waste from food and vegetable oil production, wood residues, etc. Then there is also the Gen 3 feedstock, which are derived from specially engineered high energy crops such as algae. And the Bornewables uses the Generation 2 feedstock derived solely from waste and residue streams, such as vegetable oil production, oil waste, and residues from the timber industry or the food industry. These feedstock are not competing with food crops, giving a reduced carbon footprint to the end product and decouple the plastics from the use of fossil feedstock. The renewable PP and PE solution shown here can be used in a broad range of applications like rigid packaging, appliances, flexible packaging solutions, and there are also products for fiber and hygiene applications and other specialty areas like automotive, healthcare, and infrastructure. So as mentioned earlier, these are drop-in solutions with the same mechanical properties, product safety, and recyclability as virgin material. And on the other aspect of driving circularity, we also enable our customers and brand owners to incorporate recycled content in packaging. And also in line with the Baruch circular ambition, we have embarked on our first round of MOU, signing with strategic recyclers in Asia North and Asia South. The recyclers involved are in China and also in Singapore, and these are two of our partners that that is shown in the slide, and partnering with us on PE solutions. And in the next slide, we can take a look at one of our PE offerings. Here. So over here, we have our PE recycled offer, LDP1. I think this will be LDP1. So this is a 926 density, 0.4 MFR material. And when it comes to recyclates, one of the key areas that we test in is the gel count of the material. And as you can see from the data, the 100 to 300 micron gel level of LDP1 is less than 5,000 per square meter, which is significantly better than a European reference that we have, which the European LDP reference has already been qualified by a major global brand owner for non-food packaging. So global brand owners that have commercialized packaging with recycled content has also accepted that it wouldn't be realistic or practical to compare it with the virgin level film aesthetics, and they are willing to adapt as long as the package safety and performance is up to standard. So LDP1 is suitable for non-food contact flexible applications for consumer and industrial segments, and also shrink applications. And some examples we have are in lamination, in shrink film, agriculture, overwraps, and courier bags. And these recyclates are natural colored palette with no adverse odor, with low gel count for the production of high quality, sustainable film without compromising the package performance. And with this, it also brings us to the end of today's sharing of the 4 elements of sustainable packaging and the respective actions to drive the right solutions. And to sum up today's sharing, we believe that as an industry, we should all acknowledge the trade-off between the different sustainable packaging elements, and the lowest carbon impact material may not always have the highest recyclability or the use of recycled content. It will be a multifaceted approach to act on packaging sustainability, addressing all the different elements, and there are multiple solutions to further the transformation to a more sustainable and circular economy. Thank you.
Thank you, JC. I noticed that you have a number of offers on the materials to replace the laminated structures. I think that's what we've been, I've been involved in a number of projects, especially the EPR projects and all this, and we are talking about, moving towards industry movements towards materials that is more, or products that can be more easily recycled. Now I think we are seeing a lot of technological development in this. Very good to see. Thank you very much.
Thank you.
All right. So okay, we have after 2 presentations on material technology, we're gonna move on to the presentation on recycling processing technology. We're going to invite Mr. Raymond Wong, the Managing Director of NGR Malaysia. He's going to give us a presentation on recycling, putting waste to product. Raymond Wong has founded his passion in the drive towards circular economy. The next generation recycling machining, I can't I can't pronounce this in the German, or NGI in short, has allowed him to pursue this passion by guiding businesses ranging from up and coming plastic processors or recyclers to large conglomerates and brand owners on solution towards recycling their waste. Raymond is currently the Managing Director of NGR subsidiary in Malaysia, providing solutions to Southeast Asian markets. Raymond, you can have the floor is yours.
Thank you very much, Mr. CC Chia. Let me first start to green. Give me 1 second. Still.
By the way, how do we pronounce that word again?
It should be next generation recycling machine and GmbH.
Machinen.
Yeah, machinen.
Okay.
Well, it's I took one course of German and that's about all I could pronounce up to this stage.
I only know one
Okay,
word. Good Morgan. Okay.
Morgan, yes. So thank you very much, Mr. Sisicha, for the delightful introduction. Good afternoon, ladies and gentlemen, MPMA members and colleagues in the industry. Welcome to the MPMA Plastic Month 2021, where today we focus on working with post-consumer materials. My name is Raymond Wong, and I would like to give you a brief insight into the possibilities of post-consumer recycling. However, before we proceed, I think I would like to share a little bit about the basic background information of NGR and what we do. NGR, or Next Generation Recycling Machine, GmbH, started approximately 25 years ago in a small little garage shack behind the founder's home. It has substantially grown since and is now part of the Next Generation Group, which is privately owned by 4 partners, including a minority share by Inca Group, the same group that owns IKEA. The Next Generation Group strives at being an equipment and solutions provider that revolves around the sustainability of plastics. If we take a quick look at the product life cycle of plastics, you will see what I mean. The birth of every product starts with the product design. And at this stage, we have Colin Lab and Pilot Solutions based out of Germany, which produces pilot scale equipment for laboratories and research facilities. Next, the upscaling process happens and mass production takes place. Even the most sophisticated manufacturing processes are prone to minor waste generation. Here, NGR provides efficient and effective post-industrial recycling solutions, converting unavoidable waste generation from the manufacturing process into high-quality pellets, enabling the user to reuse them back into the production process again. After consumption, NGR, together with its sister companies, Britas and NGE, provides unique solutions for the processing of post-consumer waste. NGR provides the solutions for melt preparation process, while Britas is capable of providing the melt filtration solutions for highly contaminated waste. This combination results in the clean, reusable, recycled pellets that is suitable for various applications, from film to injection molding. Any waste that is considered unrecyclable, however, would then be passed on to NGE to provide custom solutions for pyrolysis waste to energy conversion. NGR has its headquarters in Verkirchen, Upper Austria, where approximately 120 highly qualified employees design and produce high quality equipment and innovative solutions to our customers. We are also in the process of completing our new production plant that will increase our production capacity by 3-fold and will be ready by the year 2022. Together with its 3 other subsidiaries strategically located around the globe, our presence ensures that our clients are well taken care of. Ladies and gentlemen, I'm sure that you are well aware on the statistics of the amount of waste that's being used and disposed of, or the waste that's leaking into the ecosystem. Therefore, I shall not dwell on this topic too much, as we all already know that we are in a state of crisis. Let's now explore the range of solutions that we have at NGR, where we classify our waste in 3 categories. The first being post-industrial recycling, post-consumer recycling, and PET improvement. Each classification has its own unique solution. This may look rather complicated, but definitely necessary, seeing that waste comes in varying shapes and sizes, bulk densities, layer structures, amount of prints, moistures, and contamination. The most critical factor is the customer's requirements and their expectations towards the recycled materials. However, they would like to reuse the recycled pellets dictates the applied solutions. For the post-industrial segment, we have 4 separate models covering a large output range. These models are either capable of providing focused applications for inline recycling solutions or flexible offline solutions, in some cases, a combination of both. Post-consumer segment showcases 2 separate models for handling post-washed, post-consumer waste materials, resulting in high-quality pellets that can be used as feedstock for new product. And finally, the PET segment stands alone as a separate segment, as the waste feedstock could be derived from both post-industrial as well as post-consumer sources. It features an add-on decontamination process that integrates to the existing product portfolio to produce high quality comparable to virgin grade PET pellets that is food grade approved. Hence, its applications are endless, as you will experience in the focus feature segment ahead. With this range of products, I would like to put focus on 2 out of the 3 segments that we are offering. Let's start with the post-consumer recycling. Post-consumer recycling, or more commonly known as PCR, takes feedstock from waste that has been disposed of after consumption. Such waste must go through various washing and sorting processes to separate the non-plastics from the plastics and separate the individual plastic streams prior to the recycling process. NGR solution starts after the washing and sorting process is completed, leaving fairly clean plastic flakes. Post-wash film could consist of the following forms, but are generally already size reduced as a result from the washing and sorting process. The waste coming from the washing line can be relatively moist, and this can be detrimental towards the quality of the recycled pellets. To overcome this, a slightly different method of handling the waste is required. The C-Grant model in NGR's range is made specifically for post-consumer waste in mind, where a cutter compactor extruder combination preconditions the moist material sufficiently before recycling, resulting in a high quality pellet that can be used to manufacture other plastic products. Plastics waste is chopped by rotating knives in a proven concept as a cutter compactor. Specially arranged internal deflectors provide additional compacting of this material. This frictional heat densifies the plastic and force feeds it into the extruder screw. The customized extruder geometry guarantees efficient use of the preheated and compressed material from the cutter compactor. The result is a maximum output of a high degree of homogenization while minimizing energy consumption. A great example of how NGR puts collected waste back into the product is featured here by one of our clients, Silvex. Here's a short video.
The future is the result of our choices, and we all want to choose a more sustainable future. Every day we dispose of tons of plastic waste. What happens from here onwards is decisive in the increase or reduction of plastic pollution. Often this waste is sent to countries without the capacity to manage or process it, and so we are exporting a problem that is ours elsewhere, causing serious environmental problems. Can we do it differently? Can we transform these discarded materials into new products? The real problem with plastic is not the material, but what we do with it after using it. In nature, nothing is lost. Everything is transformed, just like plastic. At Silvex, we choose to do something different. Silvex's new recycling unit allows for the treatment of plastics at the end of their life, giving these materials a second life and making them circular. Tons of plastic waste from the most diverse customers arrive at this unit every single day. This material is sorted according to its origin, which will be transformed in new raw material, hence ensuring that these plastics will not pollute the environment. Sorted by polymer type and by color, using highly technologically sophisticated equipment, non-plastic materials are removed, allowing for above-average quality levels in the recycled material obtained. This step is essential for replacing virgin polymer with recycled polymer. We are making plastic from the plastic that already exists. After the first sorting process, the material is yet again sorted by optical systems by plastic type. Then going to the washing process where materials such as paper from labels and glue are removed. All of this is managed and controlled by computerized systems and connected to a state-of-the-art WWTP that allows for efficient environmental management. After these treatments, the plastic is ready to be melted in this last step that we call extrusion, which transforms the plastic into new raw material in the form of small granules. The entire recycling process at Silvex is led by strict quality control procedures so as to guarantee the highest safety possible and a wide applicability of recycled polymer in products. Bagged, these granules are then transported to another plant unit where they will be used as raw material for new products. At Silvex, we transform plastic that used to be considered as waste into new plastic and show that it is possible to do things differently. In an economy that is expected to become more and more circular, increasing the efficiency of plastic's life cycle, ensuring a high incorporation of recycled materials in the products we consume is the key to a more sustainable future. The material that had once reached the end of its lifespan is now valued and transformed into Silvex products, thus avoiding the use of new resources and contributing to the reduction of environmental pollution. In nature, nothing is lost. Everything is transformed, just like plastic.
Hey, great. Hope you enjoyed it. So for the next segment, we will look into the PET improvement. Give me 1 second. Apologies for this. No, I'm not referring to your cat at home, but more towards polyethylene terephthalate, and is one of the most unique plastic materials on Earth at the moment. Not only is it recyclable, but the chemical properties are renewable to an extent that it can be reused to produce the product it once was. This material has dominated the beverage bottle industry and is currently one of the most sought after materials in the post-consumer recycling industry. As the majority of the materials are sourced from post-consumer sources, the waste needs to go through extensive sorting, separation, and washing before NGR can take over. This complete recycling process consists of 3 modular steps, which can be interchanged depending on its input material specifications and the output requirements of the client. As you may be aware, PET is not only in beverage bottles, but also in many other items such as textiles and fabric, food trays and containers. Depending on the type of input material and its quality, different melt preparation technologies could be applied here. As an example, textile waste could be processed with NGR's post-industrial series shredder feeder extruder combination to provide melt that will subsequently be piped into NGR's P-React liquid state polycondensation system for decontamination and IV lift. The center is the P-React, which runs on the liquid state polycondensation process, or LSP for short. This process decontaminates the liquid PET and provides a substantial lift in the viscosity of the PET within a very short period of time. This, in combination with online viscosity measurement tools, the process can be controlled to the precise viscosity the user requires for the application. This results in a stable uplift of the viscosity where the PET melt is certified FDA approved. This means that the melt coming out from the P-React system can be used to produce food contact products such as bottles and trays. Since the PET melt is decontaminated and the viscosity is that of the client's target, the output, the three output devices can vary depending on its application. To provide full flexibility to the client, pellets can be produced to store and await further processes, or they could be made directly into an end product, such as filament yarn for textile production, or even PET sheet that could later be made into food trays or containers. The conditioned melt can also be fed directly into a preform injection molding machine, which that could later be made into beverage bottles again. The benefits of producing a product directly from the conditioned melt is substantial. For one, you save on the capital investment cost of an extruder required to remelt the pellets again. The second benefit is the potential energy savings of producing a product directly from conditioned melt. As you can see in the first energy balance graph, which shows the melt being made into a pellet. The second graph shows the trend of the material being made directly into a product. Pay attention to the back end of the curve where you will see the difference. If I overlap the graphs, you will see clearly that the energy saved from producing a product is there. This potential energy savings gains, which can only contribute to your bottom line. Contamination properties of the LSP process of the P-React has been tested and approved by the US FDA and as well by the EFSA. Brand owners around the globe have also given the seal of approval for our process to be used to process post-consumer recycled PET bottles into beverage bottles again. To a short illustration, I would like to show you now a short animation on how the process works. This is a process from which post-wash PET bottle flakes are made directly into preforms. Washed PET bottle flakes are first pre-dried in order to remove any excess moisture. Then the bottle flakes are melted in the extruder before being filtered by the first melt filter. The melt enters the P-React system for decontamination and viscosity lift. The volatiles are then extracted and filtered via a condensation system. The decontamination melt goes through a final melt filtration before entering the injection molding machine. The molding machine in this case produces preforms, which could then be made into beverage bottles. And GR, we have the possibilities to cooperate with the largest clients with a multitude of flexibilities in our solutions. We encourage interested clients to send us your waste to be tested in our lab facility in NGR, Austria. We have all our equipment in showcase and processing customers' materials daily so that we could accurately find the best solutions for your everyday need. I personally encourage you to come and talk to us over a cup of coffee and let us know your recycling aspirations and see how we could be able to help you. A cup of coffee doesn't hurt, but not recycling hurts Mother Nature more. And that is the end of my presentation. I hope to see you again soon. Thank you very much.
Thank you, Raymond. Thank you. Raymond, you know, a cup of coffee it does not only doesn't hurt, it helps. You know,
Yes,
I need
definitely.
a cup of coffee to start the day every single day. You know, thank you very much for your presentation on the PCR recycling technology and how, and you know, your sharing of how your customers use the NGR solutions technology to recycle PCRs into high-valued plastic products again. Thank you very much.
Thank you, Mr. Chair.
And thank you for your German accented presentation. We feel like we are in Austria, you know, at least virtually. Okay, so from Austria, maybe let's move on to Canada. You know, let's invite our next speaker, Mr. Pedro Oliveira from Husky. He's going to give us a presentation on unlocking sustainable packaging with Husky. You know, Husky is, you know, is definitely known as a technology leader in PET technology. Mr. Pedro Oliveira joined Husky in 2007, and since then he has held a variety of positions throughout the organizations in the areas of sales support, factory planning, and business development. He holds a degree of materials engineering from the Universidade do Portugal. You know, sorry, my anything outside English and Mandarin, I'm very poor. And I believe you'll be assisted by Mr. Mano George from Husky, who is the multi-layer packaging solution manager, either in the presentation or later in the Q&A session, right?
Yes, yes.
So yeah, Mr. Oliveira, you can have the floor.
Thank you very much for your presentation. Let me just start sharing my screen. Like this, I hope it works. And starting the presentation. Okay, so thank you very much for your introduction. I'm not in Canada. Canada is even earlier than here. So I'm in Luxembourg. So good afternoon to everybody from rainy Luxembourg. It's still quite early in the morning here. It is a pleasure and an honor for me and for Husky to attend this event. As you said, Husky is a top industrial company, not only on PET packaging. Yes, that's where we are better known, but also in providing solutions for the delivery of essential goods such as food packaging, but also hygiene and medicine. So I will start my presentation with what are the sustainability trends. We know that change is coming and change is needed, as Raymond just mentioned, and actually it was a very good flow to follow NGR in this presentation. We do know that there is an increased demand for sustainable packaging. We see also brands committing more and more to recyclability and to including PCR into their packaging. And we also see a little bit all over the world, Europe being a very good example of that, of a political drive to include higher content of recycling material, and also to have solutions to ensure that the circularity of plastics. So I will start there. Apologies. We see that there is an evolution of the extended producer responsibility. We see more and more EPR systems. We do believe that EPR systems are fundamental to ensure the sustainability and the circularity of plastic. So there is a trend in mature markets, a transfer from the government waste management to more industry-led resources management. And we also see in emerging markets that are more and more industry-led solutions. And also this is viewed in most of the cases as a business opportunity. So I think that for the audience here, it's a good onset of opportunities. The circularity of plastics. We see that in the region there is already some cases of deposit return systems. Is also the implementation more and more of EPRs and deposit return systems. I will come back to this and why we need. We see the examples of Germany, for example, here, where the collection rate is above 95%, and we know that in Europe there is a target to reach 80%, and in fact, with the mandatory 25% in packaging by 2025, we see that now today the collection rate is the bottleneck. So this to say that we can talk about circularity, but fundamental is to ensure that the collection system and the collection rates can cope with that. So as I said, the post-consumer rising trends and the brand owner commitments, we see a little bit all over the world commitments and even over commitments when it comes to increase of to including recycled material into the packaging. We see Coca-Cola talking about 100% rPET in most of their markets. Sprite bottles shifting to clear to support also the circularity of PET. Pepsi talking about 100% rPET in the European Union. The European Single-Use Directive, Single-Use Plastics Directive that I talked before. Mandatory contents of recycled material in 2025 and 2030, and we also see lately in Italy, Spain, and UK, we talk about plastic taxes for packagings that do not contain recycled content. There's also a movement in the region. There is the action to combat marine debris. I heard somebody talking about that during this presentation, and also the Malaysia Sustainable Plastic Alliance. So we see fortunately that the awareness and mainly in the regions where the plastic waste or the marine plastic waste is of more concern. We see more and more awareness, not only from the people, but also the consumers, but also hopefully from the industry. So in this slide, we see, and we talk about now precisely about rPET. We see that there is a challenge between supply and demand. So in the areas where there is higher commitments to include recycled plastic into the packaging, we see an increase on demand, and that has economics 101, that has immediately an impact on the price. In Europe, we are seeing 50, 70, even 100% price difference between rPET and virgin. And we see that there is a scarcity of material, and that most of our customers are looking for the material, not really being able to choose and to pick the material they want. So what is expected from this is really to have tendentially lower quality material or lower quality rPET in the market. So and this is why we do see that in the PET packaging world, the increasing use of post-consumer PCR has a clear implication. The material adds a new dimension of variability to the current equation. So when talking about PET injection molding, we always consider the conversion technology, the application. So the conversion technology being the machine, the mold, and the application, how that was processed, and now we have an additional variable that is the material and the variability that comes with this material. So as I said before, the production of rPET is done in systems like the one Raymond just mentioned before, from NGR. So there is a variability that comes from the material collection. So you see in this graph, you see the bottle to bottle application. So you see that the source of variation is significant. So if you start from the bale quality, and the bale will depend from where the bottles are collected and how the bottles are collected, if it is a deposit return system or if it is a curbside system. So all this is going to depend, or the country the bottles are collected. So this is also going to depend the type of bale. And then we have different sorting and flake processing technologies. And then we have different mechanical recycling technologies to reach rPET. And then it's when ASCII technology delivers all the way to the molded part. And then we have the production of the bottle. So we have a significant control over the process, but still we see that between material collection, material enhancement, processing, and the different application, there is a significant source of variation to which we had applied a systematic approach of understanding and understanding exactly how this variability can affect the quality of your finished good. So the ASCII suite of solutions to handle increased PCR content. So you see from left to right, our multi-layer technology. I will speak about that later in my presentation on how we can incorporate recycled material in a middle layer of a preform. We have our start of the company, the HPP5E technology, rPET ready system, the best foot forward to handle rPET applications. We have a system to end food grade flakes. I will not spend a lot of time speaking about food grade flakes because it's a material that we see rarely in the market today. And then we have our recycled melt to preform. Raymond was presenting before the capability to link a decontamination and melt the contamination unit directly to the production of preform. And this we do with our recycled melt to preform technology. So the rPET solution technology, our HPP5E, it's a system, it's our standard system, a standard solution with an integrated PET preform solution from pellet to preform. So we have the dryer, the resin preparation, the melt preparation, and the molding and conditioning of the preform, all in one system, fully integrated and controlled. Also with our extended experience in the PET processing. So as I said, the system is the best foot forward to handle rPET, but we cannot talk about one rPET. There are different types of rPET. There is very good quality rPET, but unfortunately there's also lower qualities. And as I explained before, with the market as is and as it will be within the next 5 to 10 years, there's going to be for sure difficult to source and tendentially lower quality material. And in this slide, I try to summarize the difference or the risks that come with this variability in quality of material. So the rPET is normally requests. So it's a material that requests a more gentle drying. So we need to make sure that the drying system is adequate to dry rPET. They are more so we mix two materials, and this can lead to inhomogeneous melt properties. And there's also an increased cavity to cavity variability, and the possibility of dust creation in the mold vents. And also, if the material quality is in reality low and we have a huge quantity of contaminations or black specks, those will pass through in the system, and there may be prevailing defects on your preform. And then, of course, we need to have a system that is capable to handle process deviations that can affect the part quality and consistency. Without going too much into the detail, we can propose a set of risk mitigation options in our new systems or in legacy systems to mitigate the risks I just mentioned. It's not that we need all these options all the time, but as he has a package of options that will support you to produce the best possible quality with a variable source or stream of material. This includes what you see here in terms of hardware, the different technologies in terms of hardware, but also our technologies or our soft skills on factory planning and advanced processing support. I would like also to mention the recycle melt to preform. So as we saw in the previous presentation, we can use incoming material, hot wash flakes, and produce in-house rPET pellets, and then go into in-house preform production, or we can link directly the hot wash flakes into in-house preform production by linking a multi-contamination unit like an NGR directly into an ASCII system. And this machine you see here on the screen, it's our first system that is today in production in Asia, where we have up to 30% energy savings connected directly to a multi-contamination unit. And if you remember the graph presented on the previous presentation, is where we have the savings by doing the direct link. We are not cooling, pelletizing, and then reheating again, and we are going directly into preform. Apart from the savings in energy, there's also a very interesting advantage when considering circular economies, that we give one less heat cycle to the material. So now I would like to talk a little bit about our multi-layer solutions. So since we launched our latest multi-layer technology in 2015, we still have a tremendous market acceptance. We have sold 66 machines in 14 different countries for 10 different applications, and that go from CSD, dairy, and we will also would like to mention that 50% of our customers repeat an order. So you see here different areas of application for our multi-layer technology. So for CSD and other beverages on the gas barrier, light barrier mainly for milk, and then also on applications for the aesthetics, and a very strong component also on recycling and compostability, as well as innovation. You see more on the right of the slide. So here, when mentioning a PET for those applications, we are talking about a whole new set of requirements for PET packages that can unlock growth in these different segments. So you see for CSD, we have the technology supports the barrier of CO2 for small CSD packages. Juice and ketchup, the technology is used for a barrier to should I say, penetration of O2, so a barrier for O2, also a barrier for light, for milk applications. And when we talk about beer, for example, it's all of those properties and capabilities combined. We also see the aesthetic and An example I will give on milk, dairy applications, and also on industrial pails for recyclability and sustainability. So a PT bottle is ideally suited to meet the dairy market trends. So when we consider the different mega trends, e-commerce, health conscious, differentiation, and at-home consumption, we should add sustainability to these mega trends. And a PT bottle milk is meeting all those mega trends and all those requirements. But better than me talking about or going into the detail of those of how PET meets these requirements is to show that the large global dairies are moving into this direction. So best is really the market reaction. So here you will recognize the logo of the main dairy players in the world, all adopting PET for the dairy packages and multi-layer configuration to ensure the best hygienic and protective bottle to their customers. The leaders, Danone and Lactalis, Healy, the largest dairy producer, and also national dairy producers are all setting multi-layer PET as the material and technology of choice for their packages. These brands have adopted PET for cost reduction, premium packages, and sustainability. So I've been talking about multi-layer without really going into the detail of how are multi-layer PET bottles made. So similarly to regular PET bottles, it all starts with a preform which is blown into a bottle. Only in this case, the preform has a white structure created by co-injection. So typically the core black layer is 20 to 25% by weight. And besides blocking the light transmission, it can also create an opportunity to incorporate rPET. That rPET is mixed with black colorant, and so it can be any color, including opaque rPET from recycled bottles. And this is how you see that the difference between downcycling and the circular economy of PET. We can bring a PET dairy bottle back into a PET dairy bottle with the use of rPET and incorporating that material into the middle layer that you saw on the previous slide. So you see that example is being, or that case of circularity of multi-layer PET bottles is done with those three examples. You see Parmalat, Lactalis, Danone, and Granarolo, which is the second largest producer in Italy, that are making the circularity of PET a reality. I would also like to give you an example about a pail, more on the polyolefin area, where you see the use of the recycled material in the middle layer, keeping the aesthetics and cleanliness challenges met by virgin material, and being able to incorporate the recycled material in the middle layer, reducing costs, but also lowering CO2 emissions and footprint to up to 35%. So closing my presentation and going back to previously where I talked about having a complete system and a complete partner that is an experienced system manufacturer that has a responsive service and support, and then can add you with processing, monitoring, and preventive maintenance with our Advantage Plus Elite. We call you services. We are continuously connected to your system and support you on your production. Finally, I would just like to mention how we see circularity and circular economy for rPET, and it is actually keeping the carbon in use. There are many innovations and active solutions today, showing that.
Excuse me, Mr. Oliveira, your time is up.
So I will finish
yeah.
I will just
Okay,
finish
good,
with the
good.
slide,
Thank you.
and apologies for the timing.
No problem, no problem.
I would like to mention. So I finished with the slide, and we see that the ideal state of circularity of rPET, and we believe it is possible, is to keep the carbon in use by mechanical recycling, advanced recycling, plastic to oil, so that we reduce the use of fossil fuel. So thank you, and sorry for the
No problem. You are just
lateness.
slightly
Okay.
Probably just slightly over time. Thank you very much for your your presentation on the rPET production technology, and the direct flake to preform technology, and interesting to see that PET rPET is also using in applications to replace PET HDP bottles, like the milk bottles. Very interesting.
Yeah.
Thank you very much.
You're welcome. Thank you.
Okay, next we'd like to invite our last speaker for today, Mr. Anivesh Tiwari. He's gonna present a presentation on rPET for F&B applications. Mr. Anivesh is from Indorama Ventures. He has 36 years of hands-on experience in polyester manufacturing with 8 years in PET recycling. And he holds a bachelor's of textile with the specialization in man-made fibers. Okay, let's invite Mr. Anivesh.
Yes, let me share my screen first. So hope this is visible to you. No?
Yes. Yes, yes.
Thank you much for the kind introduction. As has been said, my name is Anivesh Tiwari, and I lead Indorama Ventures recycling business in Asia. So today I would like to talk to you about our company Indorama Ventures, or IVL in short, and the recycling work that we do. Specifically, I'll cover our recycling footprint. I'll discuss the unique qualities of PET as a raw material, and I'll mention the importance of the circular economy, and finally, I'll look at how quality permeates our business. So Indorama Ventures is the largest PET producer in the world, operating in 33 countries across Africa, the Americas, Asia, and in Europe, with over 24,000 people in 125 manufacturing facilities. The unique plastic we produce and recycle is called polyethylene terephthalate, or in short PET, and is commonly used for soft drink and water bottles. Every year, Indorama Ventures turns billions of used PET bottles into new bottles, keeping them out of the environment. As global recycle in the recycling technology.
Mr. Anivesh, could you make your screen full screen? You are in presentation mode. We are seeing your presentation mode. Can you make it full screen, please?
Is it okay now?
No,
well,
it's,
who can tell him how to do it? I've forgotten how to do this.
How can you do?
Probably your display setting, is it?
I forgot which button you should click.
Is it okay now?
No, we are seeing your next screen as well.
Yeah,
your current screen
mode,
and the next screen as well.
Somebody suggest how to do it, please. Sujata? Oh, never mind. I think we'll have to carry on then, Sisi. Sorry.
What's that?
How to make it full
Sujata,
screen
how do you do it?
this presentation mode?
How to?
Make the screen full screen. He is in presentation mode. We're seeing a very tiny screen. He's
Yeah, he cannot use presentation mode. He just needs to view.
Okay, now
Okay,
it's
now
better.
we got it.
Okay, now it's okay. Now it's okay.
Nice.
Now it's
Yes,
okay.
yes,
Yeah,
Very
yeah.
good.
right.
Thank you very much.
Okay.
Sorry for that. So Indorama has built a vertically integrated and diverse business centered around PET. In 2010, we were only a PET commodity company. Gradually but systematically, we have diversified. This included backward integration into PTA, which is raw material for PET, and forward integration into packaging, where we still need to do a lot, but we are converting PET into bottles. 10 years ago, we also started building our PET recycling business. We are building circular ecosystem for PET. The world need, as PET is the only 100% recyclable plastic. Our fibers business started with polyester. Today, we serve consumers in lifestyle, hygiene, and mobility through polyester and other fibers. The third pillar of our business, integrated oxide and derivatives, or IDD, allows us to backward integrate and secure MEG supplies, which again is a raw material for the production of PET. As you can see, our growth is intentional, building off our scale PET at our core, but most importantly, our growth has sustainability running through it. Government industry recognize the value of PET not just from an economical view, but also from holistic sustainability standpoint. From 2011 to today, Indorama Ventures recycled 63 billion PET soft drinks and water bottles. But we want to go further. By 2025, we have committed to recycle 750,000 metric tons of PET baled bottles. Baled bottles, investing $1.5 billion to increase our recycling capacity by 700%. These assets will join a family of recycling facilities across Europe, North America, and Southeast Asia. Our commitment remained steadfast through the uncertainty and challenges of the global pandemic. Another issue for the misperception that all plastics are the same. If consumers don't know that PET bottles are fully recyclable or switch to packaging alternatives that have a higher carbon footprint than PET, we will lose out. There's also an undue focus on 100% recyclable PET bottles. All plastics are not the same. Some are more recyclable than others. Scapegoating individual polymers ignores the bigger challenge. PET bottles have the clear design for recycling specifications and are widely collected and recycled into new bottles. Because of this, PET is the most recycled plastic packaging in the world, with an active secondary market trading bales of collected post-consumer bottles right now. Treating all plastics the same regardless of their recyclability is as much greenwashing as claiming your packaging is recyclable when it is not. This is because it denies the honest truth that unlike a lot of plastics, PET is recycled in practice and at scale. If we continue to treat all plastics the same, we miss a huge opportunity. PET bottles are more than just recyclable. They are light and shatterproof. As a result, they use a lot less energy to make and transport compared to alternate package material, meaning that they have a much lower carbon footprint. In fact, research from Imperial College London shows replacing PET with alternatives would increase the volume of waste, increase emissions, and increase energy use. A UN environmental program report highlighted that for the same amount of beverage product, using aluminum or glass instead of PET increases the global warming potential of the packaging. The science is clear. Using and recycling PET beverage packaging will have a positive emission impact, decreasing greenhouse gas emissions. Tackling climate change, reducing greenhouse gas emissions, and achieving carbon neutrality are not our only goals. Better waste management is top of everyday people's agenda too. Glass bottles and aluminum cans do have high recycling rates. Collection rates for PET bottles are not good enough. A lot needs to be done further. In developed states in the global north, we have the concept of extended producer responsibility, or in short, EPR. EPR regulations charges fees to those that put the final product on the market for the collection and sorting of their product packaging. This funding is used to collect and sort post-consumer packaging waste. In the coming years, we can expect to see EPR become more common in Asia too. This is a lot better than the current collection rates, but I want us all to understand that it is not a finesse. By 2030, we know 9 out of 10 PET bottles will be collected in Europe. For example, nearly all EU member states have or are moving to a form of extended producer responsibility, a specialty for beverage containers called DRS, which stands for Deposit Return Scheme. In countries with these schemes, consumers are incentivized by return their bottles and cans because they will be reimbursed by the retailer with the deposit they paid, much like the money-back bottles of old. Countries with these deposit return schemes achieve collection rates of 90% and above. As in the previous presentation, someone has said that in Germany it is being followed. And it's not just Europe. Regions of Canada, Australia, and the US have started following the same policies now. Recycling is critical to our sustainable future as it delivers fewer greenhouse gases and less waste. IVL believes that the recycling properties of PET will drive through in our sector. The reasons for this are the clear as the bottle themselves. First, consumers want sustainable and recyclable packaging. PET bottles are widely collected and can be recycled into new bottles or textiles. Many governments plan to collect 90% of post-consumer PET bottles. Global brands have targets to increase recycled content in beverage packaging. This social, political, and commercial focus on recyclability creates an opportunity to enlarge our recycling investments and create a positive environment impact. Brands are including more and more recycled content in their packaging to meet consumer demands. Global names like Coca-Cola, Suntory, PepsiCo, Unilever, Danone, and Nestle have all made ambitious commitments to include up to 100% recycled plastics in their packaging. According to the Climate Bonds Initiative, investors with $45 trillion of assets under management have made public commitments to climate and responsible investment. In the future, sustainable businesses will be the investment of choice for the mainstream investment opportunities. But collective will and financial support for a closed loop circular economy face regulatory roadblocks. Major countries have not allowed for closed loop bottle-to-bottle recycling due to gaps in their food contact regulations. In developing nations, waste collection can be unregulated, ad hoc, or totally inadequate. But in the future, everyone will know what is and what is not fully recyclable. Regulation, collection, and behavior will embrace the circular economy. The linear economy of the past was about make, use, throw away. The circular economy of the future is about make, use, collect, and recycle. In the future, when we enjoy our favorite drink in a PET bottle and send it for recycling, the bottle will be collected, recycled, refilled, and back on the shelves in a matter of weeks. We see three key drivers shaping the circular economy of the future: government regulations, human behavior, and the infrastructure we are here to talk about. These make the circular economy go round. Governments can pass laws requiring collection and recycled content. Countries with optimal collection systems, the deposit return schemes, collect over 90% of the packaging. A closed loop is possible if we demand better collection regulation from government. But if the infrastructure does not exist to firstly produce recyclable material and then to recycle what is collected, the packaging will be buried or burned or leaked into the environment. No one wants that. When consumers choose a recyclable package and use their collection system, the recycling infrastructure must be in place to close the loop and keep the material in the economy. If infrastructure is not there, consumers will stop using their collection systems. Sustainability won't just happen. As an industry, we must control the controllable. Infrastructure is within our control. Building the infrastructure the world needs to deliver the circular economy is critical if we are serious about protecting our planet and our business. But to make this a reality, we need to educate people about the recycling and the circular economy. IVL launched our recycling education project in 2017 in Thailand. Our commitment is long-term, agreeing to operate the project for 30 years. The main goal is to raise awareness of waste separation and the 3 R's method, that is reduce, reuse, and recycle. And we are reaching tens of thousands of their children every year. By empowering the next generation and the knowledge to properly separate and dispose of waste, they will know how to reduce waste and protect their environment. When we conducted a comprehensive assessment of our recycling education project in 2019, we found that every baht we invested equated to 5.49 times increase in sustainability knowledge in society. Now we are working to scale our education program globally with a goal to educate million children by 2030. Consumers want quality products packaged in a way that aligns with their hopes for a sustainable future. IVL has embraced sustainability. Sustainability permeates our business model and drives us to improve our products, our operations, and our team. IVL is building the infrastructure the world needs to close the loop and delivers a circular economy for PET packaging. Our commercial success is tied to being both socially and environmentally responsible. Sustainability leadership is about being bold and standing out from the crowd. Our commitment to ESG, that is environment, social, and governance, is real and transparent. When we talk of innovations, then we are not limited to only technological innovations. Then you have to have product diversifications where you can use 100% recycled PET resins, single pellet solutions where you can get the percentage of recycling as you want, salt and pepper blended resins, recycled fibers. And as far as technology innovation is concerned, then the persons who are involved in recycling already know the main names like RMI, Starlinger, NGR, Ionica, which is a chemical recycling, all those things. And when we have a proper collection system like DRS or the other systems like extended process EPR, then we can see that when we have DRS system, then we get very clean bottles and we can get almost one bottle out of 1.25 PCR bottle we collect. So all these things need to be aligned together in order to achieve the recycling goals. So in April 2021, we launched our new brand platform, Deja. Deja is the new global low carbon performance PET, rPET, and polymer brand platform from Indorama Ventures. Deja trademark is available across flakes, pellets, fibers, and filaments formats. Working throughout the supply chain, Deja offers sustainability and leadership by giving converters credibility, retailers accreditation, and consumers the assurance of sustainability with high performance as standard. Deja demands more from PET and less from the environment by recycling and transforming PET into extraordinary innovative ingredient products across multiple applications to protect the future. The Deja range also includes the Deja carbon neutral pellet, the final carbon footprint of which is neutral through the use of recycled water, low impact water transport, recycled feedstock, and by partnering with South Pole, a leading project developer and provider of global climate solutions to offset any unavoidable emissions with carbon credits. Sustainability has been an integral element of success for IVL. We recognize that we have to demonstrate our willingness to develop and deliver on a sustainable strategy, as moving towards a sustainable economy creates many opportunities. Our sustainability strategy fully supports the vision of becoming a world-class sustainable chemical company, making great products for society, and is in line with business strategy and direction. Our goal is to ensure economic prosperity and sustainability to all our stakeholders. We measure our success not just by economic gains, but by our achievements in preserving the environment, thereby benefiting the society. IVL continues to undertake initiatives that are in line with our commitment and sustainability ambitions 2025 to increase our focus on the long-term sustainability value creation of the company through recycling, lowering our carbon footprint, increasing use of renewable energy, and developing human capital to further strengthen our position in market, while continuing to demonstrate how we are putting our sustainability strategy into practices. Everyone is talking about the circular economy, including industry. Billions in additional yearly investment in the next decades will be needed to make our world climate neutral by 2050. Across the world, people are innovating to be part of this massive investment and to secure the sustainable collection and recycling jobs that come with it. Everyone is learning that better collection and recycling can be good for environment and our economy. When you choose a PET, you are choosing a fully recyclable solution. But you must also choose to recycle it. To the circular society of the future, litter will be totally unacceptable. We must join together in learning the truth about recyclability and its role in the circular economy. On behalf of the whole Indorama Ventures family, I want to thank our hosts for their invitation and their interest. I wish everyone here today success in building that sustainable future. Thank you for recycling tomorrow, and thank you for joining us today. Thank you very much.
Thank you, Mr. Tiwari. Thank you. You are spot on in terms of time.
Yes.
And thank you for your very good presentation, highlighting the advantages of recycling PET and advantages of using PET as a material over other polymers in terms of recyclability. Thank you very much.
Thank you, sir. Thank you.
All right, that comes to the end of all the 5 outstanding presentations by 6 speakers. Before we go into the Q&A session, I would like to pass the floor to Crystal again to conduct a poll, a very quick poll. Crystal?
Yes, thank you, Mr. Chia. So right now, thank you to all speakers for your papers. Before we start the Q&A session, the Secretariat would like to run a very quick poll. Only 8 questions. We'll run it for 2 minutes just to gauge participants' feedback on the session today and to get your comments on how we can further improve MPMA's future webinar sessions. So please don't be shy. It's just a click and submit poll. So please do take part in it. We appreciate your feedback. Thank you.
Thank you, Crystal.
And your submissions will be anonymous, so don't worry about your answers. Krista, may I just take about 30 seconds to just thank all the speakers, the panelists, for their time
Yes,
to
yes.
talk
Please
to
do,
us.
Mr. Eddie Fong.
Good afternoon. I'm Eddie Fong. I'm the chairman of the organizing committee of this Plastic Month 2021. So really want to thank you and express my appreciation on behalf of the organizing committee that you have taken valuable time to speak to us. I've learned a lot about recycling, rPET. I thought PCR is only the test for COVID, but now I know PCR stands for something else too. Okay, sorry, my sick joke. So I think the presentation has really helped us to understand that rPET is totally recyclable. It can be combined in so many ways to help to reduce the use of virgin plastics material, and also that it can help to meet the net zero target many countries have put forward by 2050, 2060, and so on. So really a big thank you to all the panelists and speakers. Thank you.
Yeah, Crystal, while you're waiting for a poll, I would like also to add on to that, taking off from what Eddie has stated. First of all, thank you very much to all the sponsors, the speakers, and of course, very importantly, the participants. Even at this hour, we have 140 participants still on the list, which is fantastic. Now, today's session sums up what we have been looking at, which is a series of talks organized by the organizing committee, headed by Eddie, to touch on a very important thing, which is on sustainability. So what has happened over the last few sessions is that we have speakers touching on the great work they have done in terms of polymer technology, in terms of the machine production, extrusion processes, and also, of course, the requirements from brand owners that products now has to be more focused and designed for recyclability. So there are sessions where polymer suppliers and machine suppliers have been able to demonstrate what they have done. Then we had another session where we talk about the impact of recyclability, where we have Alan MacArthur coming on the day's webinar, as well as also Dr. Kalaniti talking about what would be the impact on climate change if we don't do something about climate change. Now, all along this, the important thing to know is whether or not it can be recycled. So today's session talks about recycling itself and what has been done. So I think these are very important things that is critical for the plastic industry, because bear in mind, a lot of attention and focus has been on plastics as far as plastics is concerned when it comes to marine litter. I think the name, when it comes to plastics, plastic is not a very good name when it's seen from the perspective of NGOs who claim that plastics is now causing a lot of problems in marine litter. Now, one key thing that we have to consider and remember is that UNIA 5, UNIA stands for United Nations Environment Assembly, is meeting in February of 2022, where Nordic nations have been promoting a proposal that the production of plastics should be cut down simply because all the talk about recycling and reduction has not taken place. So it is very important that we put together the industry's collective efforts to make sure that there is indeed a way to recycle, there is indeed a need for recycling, and there is a use for the recycled material. So I think in closing, the PLASTECH program has allowed MPMA, together with our speakers and sponsors, to put across this message that the industry is indeed putting in a lot of effort to try to do something that is necessary, which is to take care of the environment by making sure that circular economy will be something that is possible, and we will make it happen. So with that, over to you, Sisicha.
Thank you, Dato. Thank you. Thank you for giving us a reminder of our duty to recycle. I mean, I always consider myself a recycler, and I'm finding this presentation very enlightening. There are a lot of things to learn. All right. So Crystal, I suppose we can start the Q&A session, or is there anything more to do with the poll?
Yes, we have closed the poll. So Mr. Chia, you can start the Q&A session now.
Okay, great.
you.
There are so many, there's questions coming from the participants today. I'm gonna go through one by one. Hopefully we have time to cover all. If not, then we will reply by email. All right, the first questions from participant, I think this is directed to Huang Yi of Dow. That is, what is the cost difference between a virgin versus a PCR material? Should brand owners expect PCR to be more costly solution? Huang Yi, would you be able to enlighten us on this?
Sure, happy to. So I would say that at this point in time, definitely the PCR solution will be more expensive compared to the virgin solution. And this is purely because of supply and demand. As we know, the supply of PCR is very, very tight. And the solution, in order for it to have the performance similar or the same as a virgin solution, obviously a lot of different innovation and a lot of very high performance grades have to be inside the formulation, which all adds on to the cost. So whenever we are working with converters or brand owners, we are always very transparent about this, and we want to give them the best idea of exactly what that new cost is going to look like at the end of the journey, so we can, really drive towards commercialization as soon as possible.
Yeah, thank you. I myself have heard that like milk bottle flakes or repro are selling in the US for about $1,800 per ton. More expensive than the virgin HDPE. So
absolutely, the collection, the cleaning, all of that needs to be, really, really top notch and monitored. It's done correctly, so that all adds to the cost.
Yeah, so no reason for us to throw that little bottles into a dustbin. We have to bring it home and recycle.
Exactly.
Okay, second questions from Ms. Lo Hin Wee of SGW. This is directed to Dow again. I think this is directed to Daniel. Is that considered a food grade product and FDA approved? I think he's referring to the PCR material that Dow is offering.
Yes. Okay. I think you're referring to the XUS 60921.01. So at this moment, that grade is not FDA approved. So it is, we designed this resin is basically for the secondary packaging. So it's not a direct food contact, but of course that doesn't stop there. If, let's say, for example, if the converters or the brand owners is looking for those solution that is direct food contact, we do have other solution like using the bio-based material, and even in the future that will be the pyrolysis, the chemical recycling, that will be in the scope as well. So that actually can cater for those direct food contact.
Okay. Great. I think you have shared with us the application of that material to use as a shrink film for the secondary packaging. I suppose that is not food contact, but yeah. Okay, great. The third questions from Yap Jia Wen of Stanter Film, directed to, I think, yourself, Daniel. Hello, thank you for the excellent presentation on PCR. Are extrusion grade PCR PP resin available from Dow? That's the first question. If not, is there any plan to develop a PCR PP resin in the near future?
Yeah, at this moment, basically our PCR is likely to be in a polyethylene base. So near future, I don't have an answer, but likely will be still in the PE polyethylene.
Yeah. I think I think if you do not know about Dow, I think Dow do not produce any PP, right?
Yeah.
Yeah, more of a HDPE and the other kind of specialty chemical products. Yeah. Okay, question number 4. This is from Daniel Lu to JC of Baruch. Okay, PE with 5% metallized laminate. Has this been proven for its recyclability? And is this referring to mechanical recycling? And please elaborate how the metallized layer will not interfere mechanical recyclability. I think there are 3 related questions. JC, would you like me to repeat the questions?
CC Chow, JC has to step out.
Oh, okay.
Her answer is in the chat box, together with a link to her email if further information is required. So you could look for that.
Hold on.
Mr. CC Chair, I sent to the WhatsApp group, so it's the last message.
Okay, the last message.
Yeah, the participant can get her email, CC, from the.
Okay. No, I'm just saying whether she the answer is here. To answer your question, metallized laminate does not affect the sorting and recycling process. The metallized content of less than 5% in the PE film does slightly impact the recycling and or the quality of the recyclate, but the film is still recyclable, just not back into a closed loop scheme to be used in the same quality application. I'm happy to answer your questions in more detail if you, okay, so Daniel, if you want to email her, but I think her answer here is quite clear that it is still 100% recyclable, just that it cannot recycle back to the same kind of application. All right. So let's move on. Yeah.
Maybe I could add on a little
bit
to that question, because we do have customers who are recycling metallized, say PP or metallized PE. So basically, what JC mentioned is correct. You know, you can't use it for the same product again, but you can of course choose alternative products. The what happens is the metallized aluminum goes through the complete system without being filtered out. So the recyclates produced will basically be a nice silvery color. So this can be, of course, produced, just as an example, I've got a customer that has metallized PP, and he recycles his waste, and the waste, he takes it to an injection molder that makes a kind of protection for their rolls. So when you pack the larger rolls, they have a top and bottom cover to protect those rolls. So they have changed it to recycled material, and it's currently silver in color. It's just an example. But
yeah,
yes, fully recyclable mechanically.
Yeah, I think there is always you can find a suitable application for some of these more difficult to recycle material, but certainly they can be recycled. Okay, let's move on to the next question, which is question number 5. This is a question directed to Dow or Baruch. Okay, hi. I think that right now for PCR resin there is more demand than supply. It is very difficult to get hands on the supply, especially for people from the flexible film manufacturing. So the question is, would both Baruch or Dow be able to increase their capacities by 2025 to meet these demands? I think he or she is referring to the recyclates, as most brand owners are committing their targets to recycled content by this timeline. And a follow-through question, and when would this PCR resin be readily available in the market? Would Dow, someone from Dow or JC is not here, so I think we have this.
I'm happy
Daniel
to question from Dow. So yes, I think the answer is absolutely. We are looking to expand our production capabilities in the PCR space. And I think there is a very good chance that next year we will be making more announcements, not just in Asia Pacific, but in other regions globally that will have added capacity. So yes, please look forward to that.
Well, good. Maybe Huang Yi, maybe Dow can also consider working with some of the local recyclers here in Malaysia or Southeast Asia to see how the recycling industry can collaborate with Dow to expand your capacity in a way of maybe pre-processing or before the material can be processed into the final quality that you need, or maybe the recyclers here can do the collection for you, pre-treatment, something of that sort.
Yes, definitely.
Okay. All right, let's move on to question number 6. This is from Eddie Fong. Hey, Eddie. This is directed to Raymond. Any plans to make conditioned melt be fed into a special injection molding machine rather than solidify into pellets and then remelted into an injection molding machine? It would save a lot of energy. Any plans to collaborate with injection molding maker?
I think I answered that question in my presentation.
Yeah, Sisi, I asked the question before Pedro came on, so he has answered.
Yeah,
exactly.
I think there is Eddie. There are a lot of machine makers that can do that. They can feed directly the recyclates into the screw extruder or injection screw for the injection molding machine, and that's why you see from Husky and from NGR, they have the big silo on top of the machine, and that is.
So if you allow me, so what I think we're talking here is different. So what you're saying is that yes, all the machine suppliers or all the injection molding equipment can provide technologies to handle recycled material, right? So what we have developed, and we partner, we have a system in Canada with an NGR line, and we invite anybody that when they can to visit us and visit that system, is we are connecting, and Raymond showed it in his presentation, we are better than in mind. So we are connecting a melt decontamination unit directly, the melt to the injection form. So there's no extruder on the injection molding machine. So the melt is connected directly, and therefore having the saving, as Eddie was mentioning, enormous saving by not pelletizing, cooling, and then reheating the pellets again. That PT needs to be dried up to 160, 180 degrees before entering the extruder. So we save all this energy, and then we go directly into preform. So we do this in a standard ASCII HPP5E machine with what we call this recycle melt to preform module. And yes, there is a substantial energy savings, and also one less melt history into the PET, which is also a contribution to the circular economy. I don't know, Raymond, if you want to add something, please feel free.
No, Pedro, you described it perfectly.
Okay. Good.
Thank you.
So, Eddie, are you happy with the answer?
Yes, perfectly. I have a follow-on question, Pedro. Maybe I can ask it here.
Go ahead.
I know Husky makes machines that produces millions of parts per week. 96 cabins. Malaysia is a tiny market. Will you ever make a 16 cavity system for Malaysia so that we don't produce one day and have enough parts for 1 year's use? Will you ever do kind of
our focus is historically has been our focus, or our mainstream product is on the high output, as you mentioned, for sure. But we do have products that fit lower output or larger number of SKUs requirements. And we have all this, and maybe Manuel, you can also jump in on this. We have even this technology, we call it the NextPet, which is our lower throughput, smaller platform. And we have it also available with a multi-layer technology that I presented today. And this we can do 16, 24, 32, 48 cavities. And this, yes, and I invite you to get in touch, and maybe in the next occasion we can make a presentation about this platform. It will be a pleasure. I don't know, Manuel, if you want to add anything about this topic.
No, I think you mentioned it correctly. We do have a low output solution, and even as you mentioned, Pedro, very well, we're also introducing now with the low volume platform all the multi-layer functionality as well. So we will have this possibility also to incorporate recycled material with low volumes as well.
I hope I answered the question, Eddie. And if there's any interest or follow up on this, we are completely available to.
Okay, thank you very much.
You're very welcome.
Okay, Eddie, so any more? If okay, let's move to question number 9, since Eddie have injected with the 2 questions there. Okay, from Lee JY Lee of Kryberg TPE. Hi, are there any food contact regulations, example FDA, EU, GB, that is covering the use of recyclates? What are the scopes or framework those regulations focusing on? Anyone here who would like to take on these questions?
I think maybe Raymond, you can explore this a little bit more, but the question, I believe the question is a little bit confused, is about the regulations to use of PCR material. They do depend on the different regions, and they do depend on the different polymers we're speaking about. So when we talk about rPET, yes, the technology that MGR displayed is FDA approved. So the material is food approved, food contact approved, and while producing it in Europe, we need to have this EFSA, and but the EFSA is a qualification of the process on itself. So this is a little bit more complicated. I don't know, Raymond, if you want to say something on the other materials. My knowledge is limited to PET.
Yeah, for PET, Pedro is completely right. You have decontamination unit, which allows for decontamination of the PET melt. When we are talking about, for example, polypropylene or even polyethylene, which is still less in the market, but there are a lot of companies producing food-grade polyethylene. You talk about the complete process itself. So, a complete audit has to be done about the input material, where you are collecting your material. If I'm not mistaken, correct me if I'm wrong, there has to be a certain percentage of materials that has to be collected from a food contact source. So, it has to be from food containers. You can't just take plastic that has been wrapped in motor oil or stuff like that, which is not designed for
that
food
actually
contact.
in PT also, because there's only 5% non-food can be in the stream that
Exactly.
to produce a food contact PT.
Exactly. And I think for really a framework, I don't have that at the back or in my laptop, but there are frameworks available for producing, for example, HDPE, food contact based resins and so on, which I think a little bit of Googling would help a little bit, but I don't have that off the top.
Yeah, I was
go ahead. Yeah, go ahead.
No, I just wanted to add that I was in a show 2 weeks ago in Amsterdam, Plastic Recycling Show Europe, which is a very interesting show where we see a little latest discussions in the industry, and there is now a very interesting focus on so PET. The last time everybody talked only about PET. Now there is a higher focus on HDPE and polypropylene. So I think this is we're gonna see more and more movements there, and also maybe Raymond, you can add a little bit on this, because I found that a bit surprising that there's more and more movement on the the circularity of those two resins also.
I just want to add that in Malaysia, we have an additional problem apart from what Pedro and Raymond have just stated, is that we have a halal issue. Basically, what it means is that from the perspective of the religious body in Malaysia, we cannot use RPET because the current halal this context is such that anything that is from a third-party source that cannot be traced is not permissible from the halal point of view. So that's something that the authorities will have to work around this problem to see how this can be resolved, because we do have major brand owners in Malaysia who are very keen to follow the global trend towards using RPET, but they're not able to do that at this point in time. So
I think
that's something that we have to follow up through.
That's my next question.
Recently, I attended the I think there is EPR webinar and or something that is organized by, I think it's CASA, and they have the government have indeed come up with the legal framework on how to make the recycled halal. So it involved a repeated washing for like 7 times or something like that. So there is already
No, just to give you an idea is that Dato' Jana presented the other day at our conference. He brought this up. It is still a working plan, but it's just to let our international speakers know that we do have a problem that's peculiar to Malaysia.
Right.
Of course,
yes.
Yeah, sorry, go ahead.
I knew about that, so we talked with our representative in Malaysia, and I do believe that there will be a way. There will be a way to, as you said, a way to go around and to ensure that it could comply with that, because the business opportunity and also the circularity of PET needs to be.
And the process that we know of is that the washing process would have to be probably, your machine will have to put in a different washing process. Because for instance, if there are some things that are so-called contaminated by non-halal things, there will be a washing process that you have to wash 7 times using clay or mud that will be to purify the product. So the machines that is for Malaysia may have to be reconfigured to take this in consideration.
Okay, good. Thank you, Dato', for that mentioning that. Okay, we have a comment from one of the participants, Mr. Paul Fong from Dow. He's saying that if the waste collection ecosystem could help collect as much recycled items as the last with the least contamination, then we can also help to reduce the cost of cleaning and sorting, as well as having a larger volume of recovered materials, hence better economy of scale. Thank you very much. This is a comment from Paul Fong. Thank you. All right. Have I missed out any? Are there any further questions?
I
just want to add to what Paul has just mentioned. The question of cleaner materials for recycling would be what we have in our Solid Waste Management Act, which is collection at source. Okay, so unfortunately in Malaysia, collection at source has not really taken off that much.
Segregation at source.
Segregation at source, segregation and collection at source. Okay, it has not taken off very well in Malaysia. Hopefully, with the Malaysian government now going for net zero and so many other things, I think they would have to seriously consider, especially CASA, CCCHA, they will have CASA and KPKT will have to just put in the rules and regulation to make it more effective. The comment made by Paul is certainly valid and certainly worth pursuing.
Okay, good. So yeah, thank you. So last but not least, I would like to, on behalf of the organizing committee, for the MPMA Plastic Month, to express my sincere appreciation to Ms. Daniel Lee, Ms. Cheng Huang Yi, JC Lim, Raymond Wong, Mr. Pedro Oliveira, and Mr. Anivesh Tewari, who have shared their precious time to enrich us with their knowledge, views, and expert advice on a subject of working with post-consumer recycled materials. Thank you very much, and I'll pass the floor back to Crystal to close the session. Yeah, thank you.
Thank you, Mr. Cha, for moderating today's session. So, ladies and gentlemen, kindly be informed that our next and final webinar for MPMA Plastic Month 2021 is on 2nd of December, which is this Thursday, followed with the closing ceremony. We hope to see all of you joining us to celebrate the closing of MPMA's very first virtual conference. So before we end today's session, I would like to request for our speakers, moderator, distinguished guests, and the secretariat, please turn on your webcams so that we could take a group photograph. So please don't be shy.
Smile.
Right, so secretariat team ready, yeah? So I'll do a countdown. So 3, 2, 1. One more. 3, 2, 1. Got it? Got it, yeah, okay, all right. So with that, thank you very much, everyone, and see you this Thursday. Stay safe. Bye-bye.
Okay, good. Thank you. Bye-bye.
Okay, thank you. Bye-bye.
Bye-bye.
Bye-bye. Thank you very much.
Bye-bye.
Bye-bye.